Hey everyone and welcome. If you've seen one of my more popular recent videos on the 3D printed roots blower, you remember the 540 brushless motor that ended up destroying it in the long run. Well, I brought it back and this time it's on a regenerative blower. So it should be interesting to see what kind of effect this has. Hopefully this time it doesn't explode. So this new version of the regenerative blower has a few different features than the last one. It's mounted directly to the motor, and between the impeller and the motor shaft I have an aluminum adapter piece that screws or bolts to the impeller and has a spindle or a spigot on it that goes inside the bearing on the outer housing to give it extra support, because last time it exploded. Here I have them both side by side, the original, the first one I made, and the current one is the gray one. You can see, as well as the other differences I mentioned, it's about 25% smaller than the original, which is because I'm spinning it crazy fast, and the more mass spinning around, the more dangerous it is. So I also scaled down the impeller's clearance in the housing, so whatever the clearance was on the original one, it's 25% less currently. So hopefully that should improve sealing as well. If you're wondering why I was hanging on to everything, this is why. So off camera, I'd taken this flow meter and hooked it up to a 3.5 horsepower lawnmower. And at full throttle and pushing the throttle past full RPM, I only ended up with it about the second notch on the red. So I'm going to call that 3.5 horsepower for all intents and purposes and move on with my scaling from there. Basically, if I can go past that point, it should make boost on a 3.5 horsepower engine. Well, I'm decently impressed with the results I got from this. However, I think the motor is actually a little underpowered because it revs higher with no load under it, so I could probably bump up motors maybe to a 550 or something, maybe kill some RPM a little bit and shoot for a little bit lower KV. At any rate, we're seeing a good 3 pounds here with a good 3.5 horsepower, 4 horsepower. Now I'm getting the feeling that this flow meter works in kind of an exponential rate. So as it gets past the mark where I was at 3.5 horsepower, it should be like 4, 5, and 6 consecutively. So a viewer commented on a previous video that I can use a garbage bag as my test volume. So I'm going to see how long it takes for this blower to fill the garbage bag, which this one is 208 liters. So I get a ballpark it at 200 because I kind of got the end pinched off a bit. By how long it takes to fill it, which should give me a little bit more of an accurate measurement on how much air flows through the pump. So thank you very much for this idea, and you know who you are.
Shot. 3, 2, 1, go.
Well, that was fun. So I'm going to say the bag was full somewhere around 25 seconds. Just to make the math easy, we'll call it 30 seconds, and that'll give me a good conservative estimate of what it'll actually do in practice. So 200 liters comes out to about 7 cubic feet. So that comes out to about 14 cubic feet per minute. And if you want to count it at when the bag exploded, that's about a minute. So then we're down to 7. Either way, 7 comes out to about 10 horsepower, of course, without, accounting for efficiencies or inefficiencies, sorry. And so 14 would be good for about 20 horsepower, again, not accounting for inefficiencies. So at this point, I think I have something I can actually put on an engine. Should be fairly easy, being it's electric. I'm going to need a few other parts made up. As you can see here in the background, I'm drawing up a bypass, because when the supercharger's not running, the engine's still got to breathe one way or the other. It'll have a hard time breathing through the air pump itself. Ultimately, I'd like to find a go-kart with like a GX 160 or Honda Clone 160 or 200. That should be in the horsepower range, and they're fairly easy to work on, where I would see a benefit with this supercharger. I would probably have it set up with an Arduino with a couple stages and buttons, kind of like a NOS setup. So, have 2 buttons, stage 1, stage 2, with varying amounts of boost between the 2 of them. But that's pretty much all I got for now. And I got lots of interesting stuff in the works, so make sure you hit like and subscribe and ring the little bell so you can hear more from me. Otherwise, have a good one, guys, and see you later.